Okay, hi guys. So we're going to continue on with question 27. A square in an equilateral triangle are pictured below. If the square and the triangle have the same perimeter, what is the value of x? Okay, so essentially an equilateral triangle, right? Hopefully we all know that equilateral triangle means that all of our side lengths are equal. Okay, so with an equilateral triangle, the perimeter would just be equal to 3 times 7x minus 1. Okay, now with a square, of course, the square, all of the side lengths are equal, right? We know that. So perimeter of the square would just be 4 times 5x plus 3. Okay. And then we're told that the square and the perimeter the square and the triangle have the same perimeter. So what we can do is we can set those two perimeters equal to each other, right? The perimeter of the square is going to be equal to the perimeter of the triangle. So 4 times 5x plus 3 is equal to 3 times 7x minus 1. So again, I have to distribute, right? I have to do my multiplying. Okay. And then I have 20x plus 12 is equal to 21x minus 3. Now, I have to get all of my terms that have an x onto the same side, right? Because the whole point, I got to combine my like terms, and then I got to isolate for my variable. So, let's say I decide I'm going to put everything with an x over to the left side. Move that over here. Means I'm going to have to move this 12 over there. Okay, so then I have 20x minus 21x is equal to negative 3 minus 12. Okay. Well, simplifying, I get negative 1x, is equal to negative 15. Okay, dividing both sides by negative 1, I have x all alone, and x is equal to 15. Okay, with something like this, here's a case where left side, right side check is a great way to see if you have the right answer. So again, we just set up a table, left side, right side. We start with the original equation, and then we substitute in what we think is the right answer. So we start with 4 times 5x plus 3 and 3 times 7x minus 1. So 4 times 5 times 15 plus 3, and then 3 times 7, 15 minus 1. All right, so we grab our calculator. Okay, 5 times 15 is equal to 75 plus 3, 78. So 4 times 78, that's going to give us, that will give us 312. Okay, then over here we have 7 times 15 minus 1. That's 104, so 3 times 104. And we get 312 again. Okay, so since left side, right, equals right side, we know that x equals 15 has to be correct. Okay, moving on. 28. The playing chips of a board game are stored in cylindrical plastic cases. Plastic cases have a volume of 25,120 millimeters cubed and a diameter of 40 millimeters. Which of the following is closest to the height of one playing chip if 50 playing chips can fit tightly into the plastic case as shown above. Okay, let's just start by writing out the information that's given to us. Okay, so we're told that the volume of a case is equal to 25120 millimeters cubed. Okay, we also know that this, right, that's a cylinder. So we know that the equation, the volume of a cylinder, is just equal to pi r squared times h. Okay, so again, we're given the volume. We're also told that the diameter is equal to 40 millimeters. Okay, but you can see from our equation that we don't actually need diameter. What we need is radius, right? So radius is just half of diameter. It's going to be 20 millimeters. It's always half. Okay, so therefore, I also know that this height, whatever my height is, right? I know it's going to be the height of 50 chips, right? 50 chips will have a height equal to this, right? And we eventually want to figure out what the height of one chip is. But we'll deal with that later. We'll deal with that when we get there. So the very first thing we need to solve for is we need to figure out what's the height of the case. Okay? So let's set up an equation that can help us solve it. So again, right, we know that volume is equal to pi r squared h. And if we're isolating for h, we have to divide both sides by pi r squared. And we get h is equal to v divided by pi r squared. So let's put in our values. Well, the volume of this case, it's told to us, it's given. It's 25,120 millimeters cubed. Pi is just 3.14. And then r, remember, it's 20. Don't you put in that 40, because 40 is the diameter, r squared. Okay, so now we're good. We can solve for h. Just put in those numbers into our calculator. So 25,120 divided by 3.14 times 20 squared. And that gives us a height equal to 20 millimeters. Okay? And remember, that's the height of 50 chips. Okay? So the height of one chip, right? Height of chip is going to be equal to 20 millimeters divided by 50 because there's 50 chips, right? So we divide that by 50 and we get 0.4 millimeters. Okay, so that's the height of one of our chips. Okay, 29. A cylinder has a volume of 400 pi centimeters cubed and a diameter of 20 centimeters. Which of the following is closest to the height of the cylinder? Again, let's get the formula out. So volume is going to be equal to pi r squared h from your formula sheet. Okay, and we want to figure out h, right? Yeah, we're given diameter. Okay, we're given diameter, but we know that whenever we're given diameter, we're also given radius, right? So if diameter is 20, radius has to be half of that. So again, we're trying to solve for h, so let's rearrange this equation for h right off the bat. Okay, so h is going to be equal to volume divided by pi r squared, similar to the question we just did, okay? All right, so let's plug in our values. So volume, it's 400 pi, or 400 times pi. And then we have pi, r squared. So r is 10, not 20, it's radius. Okay, and then we get something nice happening here, right? We get pi canceling with pi, and we get 400 divided by 10 squared, which is 100. So we get 4. Okay, so the height of the cylinder is closest to 4 centimeters. Okay, all right, 30. 30 is a pretty tough question, but let's work our way through it, okay? So let me read it first. Sand is being poured from one container to another as shown below. The sand flows from the shaded part, right, the darker part, to the unshaded cone. The shaded part starts full of sand. The sand empties into the unshaded cone and fills it to the top. What is the height of the unshaded cone? Okay, so this question is actually providing us some indirect information. What they're telling us is that they're telling us that the volume of container 1 is equal to the volume of container 2, right? That's what they're saying, because if the first container was full of sand, right, and it emptied completely to completely fill up our second container, right, then the volumes must be identical, okay? So basically, we know that our end game is figuring out what is the height. What's the height of this cone, okay? Well, to figure out the height of that cone, we need to know the volume, right? What the volume of this is, all right? So I'm going to call this volume 2, and I'm going to call this, the whole thing here, volume 1. We're saying that volume 1 is equal to volume 2. Okay, so clearly I don't have enough information to get volume 2 because H is missing. So what I'm going to do is I'm going to start by looking at the shaded part, the shaded area. Okay, so if we look at the volume of the shaded container, which is, we're calling that V1, it's equal to the volume of the cylinder plus the volume of the cone, right? Because if you look at this container 1, it actually has 2 different shapes. It has the cylinder, right? And then it has the cone here, right? This part, the cone. So it's got 2 different shapes. Okay, so we're going to use our formula sheet and look up the equations, right? Pi r squared h, this guy, the cone, pi r squared h divided by 3. Okay, and this is from your formula sheet. So we're just going to put in values, okay? So if we look at the cylinder, we have 3.14. We have, our radius is 2.5 squared. And our height is going to be 4 centimeters. Okay, now we have 3.14 times, again, 2.5 squared. Our height is 2, and divide by 3. Okay. You know what, guys? I'm going to have to pause right here. My dog is, oh, Abby. No, okay. Sorry. Okay, so let's keep going. All right, so 3.14, sorry. Okay. 3.14 times 2.5 squared times 4. I'm going to get 78.5 plus 2.5 squared times 3.14 times 2, all divided by 3, 13.1. So that leaves us with 91.6. Okay, so that is the volume of a container 1. So now let's move on to the unshaded part. The unshaded part. So again, we know that, the volumes are equal. So volume 2 is equal to pi r squared h all divided by 3, because that's a cone, right? It's a cone, but the radius here is 3, not 2.5. Okay, so again, we know that, this volume 2, is actually identical to volume 1. So we actually know what volume 2 is. So what I'm going to do is I'm going to start to rearrange this equation and isolate for h. H is what we don't know, and it's what we're trying to find. So again, start off by multiplying both sides by 3. So I get 3 times b is equal to pi r squared h. And then divide both sides by pi r squared. Pi r squared. We're going to get h is equal to 3 times b divided by pi r squared. All right, so now we can just put in our numbers, right? Volume is 91.6 times 3 divided by pi, 3.14. Radius is 3 squared. So we put this all together, we are going to get 91.6 times 3 divided by 3.14 times 3 squared. And we end up with 9.7. 9.7 centimeters, which is H. Okay, I'm going to stop here for now. Maybe do a few more questions later. But definitely let me know if you have any questions. Please, email me, post comments to Google Classroom. I'm here to help. Okay, guys? Take care.